Hello and welcome. In this video, I'll be solving a couple of problems for functions. It's grade 11, but I think this is very much important for grade 12. So if you are grade 11 and you're watching this, please make sure that you save most of these ideas in your memory, right? In your long-term memory, I don't know. But make sure you have all these ideas next year, right? And if you're doing grade 12 and probably you're watching this for revision purposes, so please make sure that you remember most of these ideas for your tests, because some of these basic questions will be asked in your examinations, right? So if you're new to this channel, please hit the like and subscribe button, of course, just to show support and so that you can also watch more of our videos, right? So let's get straight into the first question. So here we have we given a function here, right? It's f of x, right? So this function here, it's f of x negative 2x. So it's f of x, if you can see it there, f of x negative 2x squared plus x, right? And plus 6, right? So it's copied down correctly there. So the first question here, 5.1. So they just want us to calculate the coordinate of the turning point of f, right? So I know that this is a question that most of you guys are ready to answer, and you can possibly answer these correct because you've came across this question a couple of times, right? So let's get straight into it, right? So here, if you consider a function f of x minus 2x squared plus x plus 6, right? Because this equation of a parabola, it's given on its standard form, which looks more like this. So this is the standard form of a quadratic function or of a parabola, right? So what we will do here, we'll simply make use of this useful tool, which is x minus b over 2a, right? So this is going to get us our axis of symmetry, right? So it's going to get us our axis of symmetry of the function, right? Which is simply the x coordinate of the turning point, right? Remember, this turning point here, we're expecting some x and some y value here, right? So the x value, this here, will be calculated from this formula, right? So what is our b value here? Our b value here on the equation, on the standard form, on the equation that is given on its standard form, it's simply 1. So our a value here, it's minus 2. Our b value, it's positive 1, as you can see there. So there's no coefficient there, so mathematically it's 1, right? So we can see here that our b value is 1, so substitute 1 here, and 2 times negative 2, right? So we're just simply going to punch that on our calculator, and I think you will see that the x value here, which is your axis of symmetry, it's x equal to 1 over 4, right? And we can just choose to write this on its decimal form, and I think it's going to be 0.25, right? So to get the y value, we would substitute this value of x into the original function, right, to get the corresponding y value, right? So we're going to say f of 1 over 4, right? Just put 1 over 4 there. Just plug in 1 over 4 as x into the whole equation, right? So 1 over 4 squared, and then plus 1 over 4 plus 6, right? So we're just simply going to use our calculator, and we will get that the answer here, it's 49 over 8, right? So let's just confirm. I think it should be that, right? Yes, it's going to be that. And we can change this to its decimal form, right? So it means that here, the y value here, which is this one here, it's going to be 6.125, right? So it means the coordinate here, because the question asks for the coordinates, we can simply write the coordinates for the turning point as 0.25 and 6.125, right? So I hope you'll be able to do this correctly next time, right, when the equation is given on its standard form, right? So now determine the y-intercept of f, right? So to determine the y-intercept, we will first copy down the equation of the function. So it's f of x here minus 2x squared plus x plus 6, right? So the y value here is equal to minus 2x squared plus x, right? Remember, f of x, it's just the name given to the function, right? Because we could be dealing with different functions next time, but for the sake of simplicity, we give them names, right? We name them so that we can differentiate them, right, from one another, right? So let's now get the y-intercept. So for y-intercept, we would let the x value to be 0, right? So once we let the x value to be 0, it gets very simple, because now we will be obtaining our value of y, right? And I think here, if you punch this in the calculator, you'll get that the y value will be 6, right? And the coordinate form for this, it will be 0 and 6, right? So I think that's perfectly fine there. And now we can move on to 5.3, which is the x-intercept of that. So to determine the x-intercept, right? So we can still first copy down the equation of the function. Make sure that we copy down properly, right? Yes, it's over there. So now we'll say for the x-intercept, we would let y to be 0, right? So that's the first thing we will do over there, just to make the y value 0, right? So you know that the equation here, it's in this form, so make the y value 0. Then after that, we're going to simply use our skills to solve for x, right? So to solve for x here, we can first divide by -1 every single term, right? I think the left hand side is just going to be the same, right? It's going to remain 0, or if you punch this on the calculator, you will see that it's going to give you 0, right? So this is going to give you positive 2x squared, and this is going to give you minus x, and the third one is going to give you minus 6, right? So let's go down here, and now I think you can just make use of the factorization. You can open two brackets here, right? So if you think about it here, you can just punch this on the quadratic formula, right? See that most of you guys are very much comfortable with the quadratic formula, right? So I'll advise that you punch this on the quadratic formula. So I think one of the x values here on the quadratic formula, it's 2. You'll get x as 2, and then if you go and edit, you'll get your x value as minus 3 over 2, right? So should you get that on the quadratic formula, what you can do is you can just simply reverse these factors. So if you reverse that factors, if you reverse this factor, you'll get that it's x minus 2, right? So which we can put on one of the brackets there, right? But we can't reverse a fraction, so we will have to consider first cross multiplying that, right? So you're not gonna do this on your paper, right? You'll do this separately. It's just you're just cheating just to get those factors correct, because I noticed that most of you guys can't actually factorize. So it's still not a problem if you can't factorize, but it's not late to learn how to factorize. Unfortunately, I will not do that in this video, right? But let's move on. And you see, you'll just cross multiply this and reverse that factor, and it changes its operation. So this is going to be 2x plus 3, right? I think you would have gotten that correct anyway, right? So now let's move on. I will now erase this here. We don't need this. You don't have to do that, but you can do that on a separate paper. First use quadratic formula to get there, but you have to make sure that this is already on its simplified form, right? I think that's perfectly fine there. We got those x values, right? We got those x-intercepts, right? So you can simply write the coordinates down. So it's going to be 2 and 0 and minus 3 over 2 and 0, right? So this is basically minus 1.5, right? Good. Now let's move on to another question. 5.4. 5.4, we have to sketch the function, right? I think this is very much important to know where these functions come from. I mean, how do we learn functions if we can't even sketch that function, right? So this is the most basic thing about it. We have to know how to sketch functions, right? So let's sketch this function, then we can have other discussions after, right? So now we have our function here, right? So I'm going to sketch this very much neatly. So I'll try my best. I'm not that good when it comes to sketching stuff, right? But I hope you guys are paying attention out there and possibly know how to sketch a function, right? You can feel free to pause the video and sketch the function yourself, right? But let's do it together, right? So I think here, in terms of the scales, you can see your x values. So you can just say this is minus 1 and this is 1. This is 2 and that's minus 2, right? So this is 3 and this is going to be minus 3, right? So here we can have 1, 2, 3, 4, 5 and 6, right? So I think I should just reduce the scale a little bit because we have the highest value as 6,125. I think it's that turning point over there. So right, we have to consider that, right? So we can just say this is 2 and say this is 4 and say this is 6, right? So we have to scale in such a way that we accommodate all our values, right? All our values for the function, right? So this would be 8 somewhere there, right? So in terms of sketching the function here, I think we can now sketch the function, right? So we've got an x-intercept, right? I think we've got x-intercept. The other one is 2 and 0. We can put it here. The other one is minus 1.5. So you see the importance of writing your x-intercept in the decimal form. You can simply see where the point lies, right? But if it's in the fraction form, you can't clearly see it, right? Sorry about that, I don't know what happened. So you will see that it's very much easy to read it when it's given on its decimal form, when it's written on its decimal form. I think the other x-intercept, it's minus 1.5, which is here in the middle, right? Just don't forget to write it here, that this is minus 1.5, right? So I think on your paper you're going to be having enough space there and you'll be able to sketch that properly, right? So now let's include another value here. I think it's 0.125, and or you can include the y-intercept. I think the y-intercept is somewhere here, right? It's 6 and 0, 0 and 6. So let's check on the function here. I think there is a point 0 and 6 right over there, right? That's the y-intercept, right? We have to include that as well when we sketch the function, right? The y-intercept and the x-intercepts are there now indicated properly, right? Now let's go and also include the turning point, one of the most important points of this graph, which is the parabola graph, right? So we can see that that's a quarter, right? And if we estimate this, a quarter would be somewhere there, right? But not exactly there, right? But it would be somewhere there, right? 6.12 would be a little bit above that, right? And remember, the value of a here, if it's a positive, if the value of a is positive, remember the value of a is the first coefficient, right? It's the first coefficient here. So if it's positive, the graph is going to be a smiley face graph, and if it's negative, we're going to have a frown face graph, right? So it means you can see by the shape of this graph, we are expecting a frown face graph, right? So if we connect all these dots, and the graph should possibly turn at that point, right? So just be careful here if you're doing grade 11, I noticed that most of you guys think that the graph is just going to turn on the line. So the graph is not going to turn on the line. It only turns on the line if the equation is given in this form, where we won't be having the p-value, right? And your y-intercept, it's just as easy as your turning point, right? But that's not the case. That's grade 10, right? But here, not necessarily the case, right? So this point here, which is our highest point, the maximum point, it's minus 2,5 and 6,125, right? So now let's move on to 5.5. I think this is our function. Then we can name it function f, right? Give it a name, right? Good. I think we're done with that. And then now we can move on to, okay, this is possibly minus 2 and other values here, right? We were supposed to include them, right? Let's move on now. 5.5, guys. We have to determine the values of k such that f of x has equal roots, right? So the question can say equal roots. The question can say non-equal roots. So I'm going to use this opportunity to discuss these ideas, right? To give you guys ideas to approach the question, right? You can say non-real, non-real. So it's supposed to say non-real here. Non-real roots. And then two unequal. Because that's a parabola, right? We're dealing with, right? So it's just going to be two unequal roots, right? So we'll have these different discussions, right? For the question 5.5, right? So let's talk about them. Let's talk about it. So 5.5 here, you will see that if you just have to imagine the k value as some y value here, right? And remember, a y value, it's just a horizontal line, right? So it's just a horizontal line. So if I have a y value, let's say equal to 4, so which is k value equal to 4, right? For example, it's just going to be a random line that it's a horizontal line passing through 4, right? So look at this line. This line touches our graph twice, right? So that would have been for two equal roots. For two unequal roots, right? Because it touches our y value at two, it touches our function at two different points. Do you see that? So which is the other one, it's here, the other one it's there, right? So now, but is that the only value that's gonna touch once? No, I think you can have as many k values there, right? Going down, and I think going up can have them, but I think it's up until a specific point, because once it's passing through here at k value equal to the 6.125, so this is k equal to 4, at k value is equal to 1.25, you will notice that it touches only once, right? So that's when it's having equal roots. So when it's having equal roots, I think it's specifically for k equal to 6.125. See that? That's the k value that's just going to touch the graph once, right? So they can say one root, or they can say, okay, if they say, I think the proper way to say it is to say it has equal roots. So to have equal roots means that it must be touching only once. Is that okay? I hope I'm clear enough with that. But think about this. What if you have like some random line that is actually passing through 8? What if the k value was 8 here this time around? So the k value equal to 8, it's not touching your f graph. So that's the case for non-real. But if you think about those values, right, we're going to talk about them, right? I think it's specifically like just above, like on top, above the 6.125. I think the critical value here, it's the turning point of the function, right? Because less than that, we see values touching twice, and more than that, we see values touching only once. Do you see more than that? More than the 6.125? We see values touching twice, right? So hope you guys get this. And I know it's not easy for all of us, but then we can make way to respond to these kind of questions in the exams, right? So for two equal roots, you must have the k value being less than the turning point. That value is going to touch twice. That k value is going to touch twice, right? And for this specific question, because they were asking for equal roots, you will see that it's when we have the k value passing through 1.25. 6.125, right? So I think we have it over there. Then we can move on to the last question, right? So you guys can see that for it not to touch, which is non-real roots, it's when we have a k value above 6.125, right? I don't know why did I write 129 here. It's just a mistake. 125. It's actually 125. Right. So okay, let's move on to the last question, 5.6. Right. So 5.6, if the graph of f is shifted 2 units to the right and 1 unit up to form h, right, which is the new equation, right? So what we have to do technically here is to go to the function of f of x and write this function in this form. So this form here, it's called the turning point form, right? So it's on its quadratic form here given, but then we have to rewrite this function on its standard form, on its turning point form. So to do that, you can see that the f of x here is equal to the a value here. It's the first coefficient, so we're just going to write -2. And then for this part here inside the brackets, we can look at the axis of symmetry. What's the axis of symmetry of this function? The axis of symmetry of this function was x equal to 1/4. So we can simply reverse this, right? And then rewrite it in the brackets, right? We reverse this and then we see x minus 1/4, right? So we just reverse that and we write x equal to 1/4 equal to 0, but we take this part and go and paste it inside the brackets, right? The y value, I remember, I think it was 49 over the y value of the turning point. Remember, p and q are values of the turning point, right? So we just choose to reverse the x1, the p value, right, and write its inverse operation, right? And then we write 49 over 8 here, right? So I think it's perfectly fine there with the function, right? That is the new equation of that particular function. Shift the function 2 units to the right and 1 unit up, right? Remember, so that's your new function h of x, right? So this is f of x written on the turning point form, right? So h of x, it's going to be some function which is our f of x. Because it's shifted 2 units to the right, what we will do inside the x bracket, we will -2, right? So we're going to -2 there inside. So we will -2 inside the brackets because it's a horizontal shift. So for a horizontal shift, we will minus inside or add inside the brackets, right? For this kind of a shift, horizontal, right? And then for a vertical shift, which is either up or down, we will add or subtract outside the brackets, right? So if you see this, then you see +1 outside, you know that the +1 tells you that the function must be shifted up by 1 unit, right? So how are we going to do this, right? So write down the equation of the function h of x, right? You will notice that here, because you are having the f of x function, it's going to be -2, which is bracket x minus 1/4, right? And then now we will -2 inside the brackets, right? So when we -2 inside the brackets, and the bracket, remember, it's being squared, right? So if it's being squared like this, and then we also have plus 49 over 8 outside, right? So we will add the 1 outside, right? So the horizontal shift is being performed inside, vertical shifts are being performed outside, right? Outside the brackets, right? So now I think the new equation of this function, h of x, right, if you pay attention, it's going to be minus 2 with the x value here. Then you will just go and simplify that, and I think it's going to give you minus 9 over 4 squared, right? And the part outside here, the brackets, right, this part, it's going to give you plus 57 over 8, right? Possibly a question can ask you the turning point of this. So the turning point of this, it's just going to be 9 over 4 and 57 over 8, right? That's going to be the turning point of this new function. But for this question, I think we're done. Now let's move on to another question, right? So let's do this quickly, right? Hope now you're gaining the momentum, right? You're in it now. You understand what's happening, right? Good. Let's go. So in this question, right, the diagram below, right? So the diagram below shows the function f of x and g of x, right? So we've got f of x function here and g of x, right? Remember, f of x here, we can see clearly that, oh, this is the parabola function, right? So it's this one here, it's a parabola function, and that other graph there that's given, which is the function g, that's the exponential, right? So we give these functions names so that we can differentiate them, right? Because if all these functions were just having y, we wouldn't know which one which is which, right? I think now it's very much simple. We can differentiate them very easily, right? Good. Now let's get straight into the first question there. So they're saying that the graph f cuts the x-axis at, okay, you can read that. I think you can all see that information there from the graphs, right? So but I prefer that you read all the information, because some of the ideas might be there and you can't clearly see them, right? Right, so let's get straight into the first question. 6.1. So 6.1 here, they want us to write down the equation of the asymptote of g, right? So g is this function, that's the exponential function. So let's first copy down its equation. So g of x is equal to 1 over 2 x plus 1 with the minus 4. Right, so write down the equation of the asymptote of that function, right? So the asymptote of this function is this line here. We can see that the graph, it's not necessarily going to touch the line, but it appears approaching the line, right? But graphically, we looked at an asymptote as some horizontal line or a vertical line that a graph will not necessarily touch, right? So in this case, the graph won't touch this line. And what is this line? What is the equation of this line? But I told you that an equation of a horizontal line, it's y equal to something, right? So in this case, we see that we're just going to simply write that the y value should not, the y value, it's equal to minus 4. So that's the asymptote of that function, right? Which is the exponential function, right? Good. Now let's move on to 6.2, right? So moving on to 6.2, they need coordinates of d, right? So usually when they ask for coordinates of a specific point, you have to ask yourself, what is that point, right? So in this case here, that point, it's the turning point, right? And if we copy down the equation, f of x is equal to minus x minus 3 squared plus 25. We can see that, oh, this is the turning point form, right? Can see that this is the turning point form of this parabola, right? So now we can see here that that's the turning point form. So now, but what is the coordinates of d, right? So the coordinates of d, I advised you that you look at this part here, you take that part inside, you equate it to 0, right? Transpose. So x would be equal to 3, right? So that's still the axis of symmetry, right? So we've gotten the axis of symmetry here, right? If a question is asking for x of symmetry next time, you must be able to say, oh, the x value, it's just the inverse operation of what's inside, right? So I think by that time you understand and you'll be much more comfortable and confident, right? So the y value for this, it's 25, right? But the coordinates of d, right, because we have to answer the question, it's 3 and 25. Let's move on to the next question, 6.3. It was very easy to get the coordinates of the turning point when the thing is given on the standard form, on the turning point form, right? But if it's given on the it's very easy to get the equation or the coordinates of the turning point if the equation is given on the turning point form, because we will just simply look and tell what are the coordinates, right? Than when it's given on the standard form, because you have to memorize this minus b over 2a stuff, right? Good. So now let's move on to 6.3. Determine or write down the range of f, right? What is f? F is this function, and now what is the coordinates of that? It's 3 and 25, right? What is the range of this function? I think the range of this function is basically the y values, right? But looking at this function, it has got a maximum here, right? So this is its maximum, right? So this is the y value at maximum. It's somewhere here, right? And I think the graph exists going down from that, right? But remember, we look from the smallest values, right? I think the smallest values are coming all the way from the negative, right? From the negative infinity here all the way to that, right? So the y values here, we can write that the y value, the range of this function, the function exists from negative infinity all the way until the maximum value 25, right? So we will include 25, right? We'll put this kind of a bracket because we include 25. 25, it's our turning point, our y value of the turning point, right? We should include it, right? It's not an asymptote. If it was an asymptote, we were not gonna include it, right? Good. So now let's move on. Someone can write that because the graph is a frown face, because the a value is positive, and then now it means that the y should be greater or equal to 25, right? You can also write it like this, right, for the range of that function, right? So whichever way you prefer, make sure that you remember that in the examination, of course, right? So now let's go and calculate the length of EB, right? So to calculate the length of EB, so we look at EB here. So, but because this E and B are basically points, are basically vertical point, right? So we can just write y at the top minus y at the bottom, right? That's what we can possibly do. And then now what we can do is we can substitute the functions here, but then because this is very much simple, there's no need to complicate it, because this, we're having E and B as our points on the y-intercept, right? On the y-axis, right? So these are y-intercept, so we will look for the coordinates of both the points, right? Point E and point B, right? So for point E, right, so that's the y-intercept, right? So that's basically the y-intercept for function f, right? You can see that that's the y-intercept for function f. So we let x to be 0, right, for that specific function. So what is the equation of the function? F of x is equal to minus x minus 3 squared plus 25, right? And then now when we let the y value to be 0, so when we let x value to be 0, it's going to be f of 0 minus 0 minus 3 squared plus 25, and you will see that the y value here will be 16, right? So it means that the coordinates here, it's going to be 0 and 16, right? So I think that's good. So now let's get the point B. So for point B, we can still get the y-intercept, where it involves making the x value 0 for the function g, right? So what's the function of g of x here? It's 1 over 2 x plus 1 minus 4, right? So that's the equation of that, right? So let's make the y value, let's make the x value 0, right? So it's going to be g of 0 here, 2 times 1 over 2, 0 plus 1 on the equation of the function. And I think if you do that properly, you will see that the value would be, here it's -3, right? So now we'll take a look at the functions, right? There's two functions. So which one is at the top? Which y value is at the top? Because this one is 16 here and 16. Someone can use distance formula because they have two coordinates, right? So if you don't understand what I'm doing, you can just simply use distance formula because you've gotten the coordinates right now, right? But I just want you guys to be more advanced and know how to deal with the vertical lines. Just gonna be this y value at the top, right? So the y value is 16, and so this is going to be 16, and the y value at the bottom, it's -3, right? It's -3. So when we subtract the two, we will see that the answer is 19 units, right? If I'm not mistaken. So I hope you get the idea, right? So next time this idea is going to be used in form of expressions and stuff, right? But you should be able to do it still, right? So 6.5 here. So determine the values of x for which f is decreasing, right? So why is the function f decreasing? Remember, we read the graph from the left, right? But remember, we're looking for the values of x, right? So we read the graph from the left, from left to right, right? So from these x values going to the right, what do you guys notice about the function f? What I notice is that, okay, obviously there's a turning point here, and this turning point here, the x value of the turning point is 3, right? Which is the axis of symmetry. So that's why it's called the axis of symmetry, because it cuts the graph into 2 equal halves, right? But according to what I notice here, the graph is increasing. So this graph here, it's increasing, right? So, but where is the graph increasing? All the way from negative infinity. So the graph is increasing from negative infinity, right, until the 3. Do you see that? It's until this. So this is the part where the graph is increasing, right? And if you take a look at the parts where the graph is decreasing, which is this part, so the graph is decreasing here, right? So where is the graph decreasing? I think exactly from the 3 and to positive infinity, right? So the green part here would show the portion where the graph is increasing. It's going up until the turning point. What's the purpose of the turning point? Obviously something was happening and now something is happening, right? It was increasing, then now it's decreasing, right? So for decreasing, you would write the part in, for increasing, you would write the part in green, and which is this. X is an element of that. And I think for most of you guys who are not comfortable with this, I think now you're starting to get an idea, because we were looking specifically at the values of x for which that does something, right? So if that's decreasing, I think it's when we move from this to the right hand side. And going to the right hand side of that, that's the part where the graph is decreasing, and it's from 3 to positive infinity, right? Which is written in this form, right? So allow me to write that it's when x is an element of 3, from 3 to positive infinity. But for those of you guys who are comfortable with using equal signs and greater, using the signs, you can just write that x is greater than 3. So here the x is greater than 3 for this solution, right? Here the x would have been less than 3, right? but here the x would have been greater than 3, right? So I think it's perfectly fine there, right? But for grade 12s, next time, if you're watching this and you're doing grade 12, this question here, they can just simply put f prime, then make it less than 0. So don't get confused. If you see this, it means that the function is decreasing. So you will write me this solution. You will write this solution. You will write this as the solution for the question, right? And if you see the prime 0, it means where where that graph of f is increasing, right? So we will not dwell much into it because this is for grade 11s, right? Specifically, right? So I think it's perfectly fine there with that. So let's move on to 6.6. Question 6.6. So now for this question 6.6, now they say calculate the average gradient. So average gradient is nothing but just the normal gradient that you guys know, MAB, right? Y at B minus y at A over x at B minus x at A, right? So because we already have the B's coordinate, I think this was the coordinate for B, right? And I think we calculated the y-intercept there, right? Because the B's coordinate, I think it's just going to be 0 and minus 3, right? So I'm just going to note it down before I erase it because we will need that. So it's 0 and minus 3, right? So let's erase this part just to have space, right? How can we get the coordinates of A though? Do we have the coordinates of A to get the gradient? No. But how can we get the coordinates of A? Looking at A here, so let me erase here and clear and have some space here. Hope you guys took notes of that. Took note of that. But let's just move on and look at the coordinates for this point, right? So we can either use both the functions. We can either use the f of x or the g of x function, right? But let's use the f of x function for that specifically, right? Just for the sake of simplicity, right? So at that point there, it's just the x-intercept for both the functions, right? So we will use the f of x function, which is minus x minus 3 squared plus 25, right? So for x-intercept, we let the y value to be 0. So 0 is equal to minus that squared plus 25, which is equal to 0. And I think now you guys can just transpose that side, right? For the sake of simplicity, let's just transpose that term that side. It's going to be a positive bracket this time around, still equal to 25, right? And then introduce the square root here and there. And remember, when we introduce the square root, we get plus minus 5, right? So this is x minus 3. And then now we're going to have two separate solutions, right? One where x minus 3 is equal to 5, or x minus 3 is equal to negative 5, right? So now let's transpose these values that side. We're going to get two separate solutions. So the other one is 5 plus 3, which is 8. And the other one is x equal to minus 5 plus 3, which is going to give us negative 2, right? So which one is negative 2 here? Possibly this is going to be negative 2. And this other one here, the 8 is for the other one, right? And I think with the distance, you can agree that I travel 2 units to go to that point from the origin. I travel 8 units to go to that point, right? So now remember, back to the question, we're supposed to get the coordinates of A, right? What is the coordinates of A? It's minus 2 and 0. I think now we can, and then the B coordinates was 0 and minus 3. Right, so now we can just get the gradient between the 2 points, right, which should be very much simple for everyone now. So we can say minus 3 minus 0 minus and then 0 minus negative 2. So I think you get that minus 3 over 2. That's the gradient of that point, right? So now let's quickly move on to 6.7, right? So moving on to 6.7, the graph of t. Graph t is obtained by reflecting g about the x-axis, right? So write down the range of t, right? So the graph of t is just the new function, right, which they are reflecting g of x, right? So let's first copy down the g of x function, which is this, x plus 1, right? I think it was minus 4. First to remember, let's just confirm there. Yes, that is the correct equation there. Now let's move on. So the y value here, it's 2. So we'll change the g of x and write in the y form and write y in the position of that, right? So that's the first thing we do, right? And please take note that if you're reflecting something about the x-axis, you will change the y value to a negative y. That's the first thing. That's one thing you have to do, of course, right? But and then if you're reflecting this about the y-axis, hope you guys are taking notes there, right? Because this is in the book and you have to remember this. You will change x to minus x. So everywhere where you see x on the function, you will just put minus x. You'll replace x with minus x, right? Then in this function, what we're gonna do is we will replace y with minus y. Let's put that into practice, right? And if that happens, you guys will see that if we divide this by negative 1, we will get that the y value here, it's going to be minus 2, 1 over 2, x plus 1, and plus 4, right? So we've reflected the graph about the x-axis, right? So this is the new equation, right? So this is basically t of x. That's the new equation of that function, right? And if you look at it, this here, our asymptote, it's the asymptote of this new function, it's y equal to 4. That's the equation of the asymptote, right? But to answer this question, I want us to go back and take a look at this graphically, right? What it means, right? So graphically what it means is that let's see our graph of g here. So the graph of g is this one, right? So that's the graph of g there with its asymptote. I think its asymptote, it's this one, it's y equal to 4, right? And now let's see how we can perform the reflection. So this is the x-axis. So how do you perform the reflection here, right? A reflection is basically this arm. You place a mirror here, right? You will see that this arm here would be looking like this, right? And then this arm of the function, this one, it would look like that. It will just look like something like this. Do you see that? So I think you will see that this asymptote here of the function will be somewhere there, right? Because here it's 4, so this one it's minus 4, right? It's y equal to minus 4, right? And the other one would be y value equal to 4. Do you see that? So now, what can you guys say about the range of this function? I think this function has got like the maximum value there, right? Like it's not passing through this line, that green one. So that green one, it's the t of x, basically. So this equation we have over here, which is the t of x equation, and I think you can agree with me that even its asymptotes correspond, right, to the reflection, right? Which is good, because this is the asymptote here through transformations on the function, and it corresponds with the one we got from the equation, from performing necessary things on the equation, right? Necessary transformations on the equation, right? So now let's get the range of that. I think it's all the way from negative infinity, as you can see here. The y values here all the way from negative infinity to the asymptote. So the asymptote is the graph, it's just below the asymptote. So one student would write that the y value, the range of that, the y value is just below the 4, right? And someone would write that y is an element of all the numbers from negative infinity until the 4, and not including the 4, because the 4, it's an asymptote, right? So you would write that y is less than 4 for that 6.8, I think 6.8, 6.7 question. You would write that, right? So you'd write that the y value is less than 4, or the y value is an element of all the values from negative infinity until the 4, right? And excluding the 4, right? So 6.8, let's move on quickly and get done with these questions. So p of x here, it's just the function f of x plus 2, right? So what is the function f of x? Remember, f of x was just that function there. So what is this if we analyze this? So for me, because I'm not seeing any transformation inside, or sorry, I'm not seeing anything changed inside the brackets, it means that there's no horizontal shift. So if you see a minus inside here, it means that there was a reflection about the y-axis, right? If you see a negative inside, there was a reflection about the y-axis. But what do you see inside there? You're not seeing anything. You're not seeing plus something, right? Meaning that no transformation, no horizontal transformation, right? No horizontal shift, basically, which is good. So looking at this, yes, we have 2 units up because we're adding, right? So if they add outside, if they add or subtract outside, it's up or down, right? For subtracting, of course, right? So here they move 2 units up, right? So if we take a look at it, and now someone is asking you the coordinates of that, right? The coordinates of the turning point, if the p of x is a new function where the function of f, it's being shifted 2 units up. So now I've already explained it. Maybe you didn't understand what is this, and I noticed that some of you guys just really don't understand what's happening there on the question, right? But should you understand what's happening, you will be able to write down those coordinates that they're looking for, right? Without even doing transformations on the equation itself, right? So you can just go and perform transformations on the graph, because we understand that p of x is a new function, right? That is our function f shifted 2 units up. So what are the coordinates of this? It was 3 and 25. So if we shift this 2 units up, that is going to only affect the y value, because the y value is here, it's 25. The x of symmetry stays the same because it's x equals to 3, right? If I shift this point up by 1 and 2, I'm just gonna have the x value, I'm just gonna have the x value being 3, but then the y value it would change to 27, right? Because we added 2 on the y value, right? Hope you guys understand. That's the correct answer through transformation, through or performing transformations on the graph, right? But let's get an answer using the equation, right? So the equation of f of x is this, right? Plus 25, and then we add outside, right? Not inside. So p of x here, it's going to be minus, it's going to be that, and then 27, right? Then if I ask you the coordinates of the turning point of this, you know that, oh, it's just 3 and 27. And I think we did that both ways, and I hope you guys understand, because we spent time discussing this, and I hope that you guys, this will stick in your memory for quite long, right? Because we're gonna need most of these ideas next year, right? For grade 11s, right? For grade 12s, if you're watching this and you're probably doing revision, good luck. Okay, so determine the value of k for which the straight line, this will be a tangent. So what you'll do there, it's that you will just simply equate the two functions. It's f of x and the y value, the straight line, right? But for it to be a tangent, okay, let's see. Let's first equate these things and see what happens, right? So this is minus x minus 3 squared plus 25, right? And the y value is 2x plus k, right? So now we're going to solve this equation, right? So I think we will need your solving skills, guys. So this is just going to be x squared minus 6x plus 9, right? I jumped a step. You would open two brackets, do the foiling, do all the necessary things, simplification and stuff, adding of like terms and all that, right? You guys are going to do that, of course. So here you will multiply this. It's going to give you minus that, distribute, and distribute this is plus 6x, distribute that, it's going to give you minus 9 with the 25 here, right? Minus 2x minus k, then equal to 0, right? So this is minus x squared. Then when you simplify this and that, these are like terms, they give us plus 4x, and then this and this would give us plus 16, if I'm not mistaken, minus k, right? Equal to 0. So I think now you'll end up with just an equation, right? And it has a variable k, right? So you still remember those questions where you guys are solving the discriminants that involves discriminants and stuff, right? So just take a quick look at this. So if it has got equal roots, if it has got non-real, so for non-real roots we will have the discriminant less than 0. So that's for not a tangent. You guys are going to solve this for it not to be a tangent or not intersect, something like that, right? But for what situations where we've got real roots, so if the roots are real, then they can either be equal roots, right? So meaning that you'll be solving the discriminant equal to 0. That's for tangent. Is that okay? Hope you guys understand what's happening there. So for unequal roots, I don't know, but it can be a tangent. I think you'll be solving that greater than 0, and it's gonna be a secant. So that line like possibly touches twice, right? So here, let's evaluate the discriminant quickly. B squared minus 4ac, right? So what is the a value? Minus 1. What is the b value? 4. What is the c value? It's 16 minus k, which is this part here, right? So what is b squared here? So the b squared, it's 4 squared minus 4 times negative 1, 16 minus k. So the discriminant is 16, and then if we multiply this and that, we're gonna get plus 4 with the 16 minus k, right? So now the discriminant in this situation, it's gonna be 16 plus 72. It's not 72, let's check that. Oh, it's actually 64 minus k minus 4k. Let's not make mistakes. Yes, and I think if you simplify this, it's gonna be 80 minus 4k, right? So remember, you have determined the discriminant, right? So if this question was saying for it not to be, determine the values of k, for this not to be a tangent, right? Obviously you would be solving the discriminant less than 0, right? But because they said solve for this to be a tangent, right, it means that you must make the discriminant equal to 0. So what is your discriminant? So your discriminant, it's 80. It's 80 minus 4k, right, equal to 0. Then you can transpose that side, and 80 equal to 4k, right? Dividing both sides by 4, it will lead you to the correct k value. So for which mainly means that for this line here, 2x plus k to be a tangent, we must have a specific value of k to be 20. Do you see that? So for that to touch our graph only once, right? So we must have the k value 20. Must have the k value to be 20. So possibly that's what it means, right? That is what it means. So I think that's perfectly fine there with that. And hope you guys learned a lot from this, even if it's a whole 1 hour video for 2 questions, right? But most importantly is to get you guys going and get you guys in the mood for the maths, right? So I think it's perfectly fine with this, and I hope you guys will enjoy, and bye bye.